name is Homnath Panta, and today I'm going to be talking about the capital budgeting. So basically, in this class, I'm going to be talking about the capital budgeting. So I will introduce you what is capital budgeting. We'll talk about the capital budgeting techniques, which include net present value, internal rate of return, the modified internal rate of return, the payback period, the discounted payback period, and the profitability index. I'll also talk about other issues in capital budgeting, capital rationing, and the capital budgeting practice. After watching this lecture video, you should be able to know the capital budgeting process, compute NPV, IRR, modified internal rate of return, profitability index, payback and discounted payback period for proposed projects, and apply them in project selection. Explain the strength and weaknesses of each of these capital budgeting techniques. Okay, so these are the main learning objectives of this class. So let's get it started. So what is capital budgeting? Basically, capital budgeting is a vague term to define. So the definition of capital depends on the context. Okay, so the capital budgeting is the process of analyzing projects to determine whether they should be undertaken or not. Okay, so capital budgeting is the process of analyzing projects to determine whether they should be undertaken. So basically, it is an investment appraisal. It's an analysis of potential additions to fixed assets, long-term decision, and involves large expenditure. So it is very important for firm's future. Once you invest in capital budgets, once you invest in a large project, basically this type of projects are irreversible. Once you start, you cannot reverse back these projects because there is a huge commitment of capital. The reasons for capital budgeting are acquisition. For example, if you want to acquire new facilities or maybe to increase the level of output, you want to acquire new facilities to produce new products. It's a replacement of existing facilities to reduce cost, replacement of worn out equipment, safety or environmental projects, and the research and development. Okay, so there are several reasons you have capital. You need to apply capital budgeting techniques. Let's watch this short let's watch this short video clip, which gives you very good overview of the capital budgeting.
Now we're going on to capital budgeting, where we're looking at decisions that companies make on the investment in fixed assets, or long-term assets. And we're using, again, time value of money. What happens in capital budgeting is that forecasts are made of the cash flows that will come in from a particular project. The company makes an investment, it'll get some cash flows. Then we'll find the present value of those cash flows, discounted at the cost of capital, and that would be the present value of the asset. We'll compare that with its cost. If the present value of the cash flows are greater than the cost of the project, then the project is acceptable. It would have then what we call a positive net present value. We could also find the rate of return on the project. Given the cash flows, given the cost, we could find what rate of return the project would provide. That would be called the internal rate of return. The internal rate of return and the net present value are the two primary criteria that are used by companies in deciding whether or not to take on fixed asset investments. If the net present value is positive, then the project, if you take it on, would create value for stockholders, increase the stock price. Or if the internal rate of return on the project is greater than the cost of capital, then again, it would be a good project. The company should take it on because it's earning more than its cost of capital. So in this chapter, we're looking at the criteria that are used to evaluate projects, namely and principally the NPV and the IRR. There are a couple of other ways that the things that are used, the payback and so on. But the two main ones that you need to be concerned with are going to be the IRR, internal rate of return, and the net present value. We'll go on to use those in subsequent chapters, but this chapter, I want you to learn how to use the NPV and the IRR, how to calculate them and use them and what they mean.
Okay, so in this short video clip, you learned that capital budgeting involves, projecting cost and benefits of a project and use appropriate techniques to find out if the project is a good project or not acceptable project. Okay, so in this chapter again, you're going to be using time value of money concept to decide if this project is a good project or not a good project. Okay, so basically there are different types of projects. Some projects are independent and some projects are mutually exclusive. And what is independent project mean? So basically, if you acceptance of one project does not prevent the acceptance of another. In that case, this is the example of independent project. If you accept one project, then you cannot accept another project. In that case, this is mutually exclusive projects. Contingent project is basically acceptance of one project requires the adoption of other projects. Okay, so there are different types of projects. They include independent projects, mutually exclusive projects, and contingent projects. Okay, so if a project is not related to the other project, so basically acceptance of one project does not prevent the acceptance of another project. This is called independent project. If the acceptance of one project prevents the acceptance of another project, we call mutually exclusive projects. And if the acceptance of one project requires the adoption of other projects, then we call them contingent projects. Okay, so cash flow in projects could be conventional and non-conventional. Conventional basically means there is only one sign change in cash flow. So basically, first one is going to be your investment, and the rest of them, they're going to be positive cash flows. So this is a conventional cash flow example. Sometimes you invest, so this initial investment is negative, but the cash flows in future could be negative. In this example here, you have first investment negative and you have cash inflow, which is positive, so you made profit. Cash inflow positive, and this third cash flow is actually you didn't make money here, actually you lose money here. Okay, so this is not an investment, but it is negative cash flow, and this is positive. So this is an example of non-conventional cash flow. So as I explained earlier, mutually exclusive projects means if you take one project, you cannot take another project. Independent project means you can choose several projects. Okay, so you can take a list of the projects. In mutually exclusive projects, you can choose only one of the several potential projects. Okay, you rank all of these projects and choose the best one. If it is independent projects, you're going to be choosing all these projects. So accepting or rejecting one project does not affect the decision of other projects. That's the case of independent project. But all these project selection criteria must exceed minimum acceptance criteria. Okay, so that's the basic thing. You have to have the minimum acceptance criteria to be fulfilled to accept these projects. Either it's independent or mutually exclusive project. How do you do capital budgeting? So first of all, you're going to estimate cost and benefit of the project. Okay, so you estimate cash flows, basically cash inflows and outflows. And you assess riskiness of cash flows. Based on the riskiness of the cash flows, you determine the appropriate discount rate, appropriate cost of capital, and compute NPV or IRR or whatever criteria your company is using. Could be profitability index or MIRR or payback period or discounted payback period. So find those numbers and based on the rule decide if the project is good project or non-acceptable project, unacceptable project. In this case, if you are using NPV or IRR, accept the project if NPV is greater than 0 or IRR is greater than cost of capital. Okay, these are the criteria. There are different categories of capital budgeting projects. They include replacement to continue profitable operation. So if you want to replace a machine, so that's about replacement. So replacement to reduce cost. Sometimes maybe replacing a machine can reduce the cost. Extension of the existing products or markets. So maybe you want to increase the number of machines to produce goods. Expansion in new products or market. Okay, so you are talking about expansion of existing products or expansion of new products. Contraction decisions, safety and environmental projects, merger, and there are several other examples. You can use um, capital budgeting. Uh, so there could be other projects. Okay, capital budgeting project categories. There are different categories of capital budgeting projects. They include replacement to continue profitable operation, replacement to reduce cost. For example, you are replacing a old machine to new machine so that it can reduce the cost of the maintenance. Expansion of existing products or markets, expansion into new products or markets, contraction decision, safety and or environmental projects, merger, and other projects. Okay, so there are several different types of uh, capital budgeting projects. So let's consider this example here. We have two projects. We have project Q and project S. So you estimated that it's going to be costing you $25 million. And then the cash flows are 15 million, 10 million, 500 million, and 100 million. So this one is cost, and these four are cash flows, cash inflows. Cash outflows, negative. Cash inflows, positive. Okay. Same thing here, project S. So you have the same cost, but the pattern of the cash flows are different here. In the first project, you have bigger cash inflows in the beginning, and the cash flows is decreasing going forward. In the second project, we have smaller cash flows and it's gradually increasing going forward. Okay, so these are two types of projects, two different projects we gonna be working on this class. Okay, so let's talk about capital budgeting techniques. And one of the important one is net present value. Net present value is basically it's the present value of all future cash flow minus cost. Okay, so estimating NPV, first of all, you need to have the future cash flows, and you need to have the discount rate, and you need to have the initial cost. So look at this formula here. NPV equals to sum of the all future cash flow, which is the present value, minus cost. To find the present value, you need to know the cash flows, okay, future cash flows, and you need to know the discount rate. Also, you need to know the cost of the project. According to NPV, the acceptance criteria, minimum acceptance criteria is the project must have NPV greater than 0 to be acceptable project. If the projects are mutually exclusive, you can choose only one project, but choose one with the highest NPV. If the projects are independent, you can choose several projects as long as those projects meet this criteria. NPV is greater than 0. So why should we use NPV? NPV, accepting positive NPV projects, accepting positive NPV projects benefits shareholders because NPV uses cash flows. Okay, because NPV uses cash flows, not the cash. It uses all cash flows of the project. Use time value of money concept and provides measure of value creation. Okay, so these are the reason we use NPV. And the reinvestment assumption in NPV, the NPV rules assume that all cash flows can be reinvested at the discount rate. Okay, so this is about NPV. And the main advantage of NPV are it considers all cash flows. It considers time value of money, and it measures value create. It's a measures and it measures value created for shareholders. Okay, so the main advantage of NPV are considers all future cash flows, considers time value of money, measures value created for shareholders. Okay, these are the main advantages. And the disadvantages is maybe it's difficult to understand. It's difficult to communicate dollar versus return, percentage return. Okay, so dollar return versus percentage return, which is complicated. It's sometimes difficult to understand. In capital budgeting, we're gonna have cash flow in the beginning. Okay, so cash flow in the beginning. Here we have cash flow at time zero. Sorry. Uh, when we are talking about capital budgeting, we're gonna have cost in the beginning. So at time zero, we have cost, which is negative, and then at the end of the each period, we're gonna have cash inflow. Okay. So this is a typical example. We have cost here, and then we have future cash flows, which are all positive. So it's a conventional example. Okay. So let's use our two projects, Project Q and Project S, and let's find out NPV. Okay. So as you know that NPV equals to present value of all future cash flow minus the cost, right? So let's take the example of the Q project. So our cost is 25 million, and then our cash flows are 15, 1,500, 100. So each of them let's discount. The first cash flow is going to be discounted one time. Second one is going to be discounted two times. Third one is going to be discounted in the three times. And the fourth one is going to be discounted four times. Okay. So you find the present value of all of these and take out the cost is going to give you $55.92. Okay. So basically it's in million, $55.92 million. That's the net present value of project Q. On the other hand, the net present value of project S is negative 257.77 million. So definitely using NPV criteria, we're gonna be choosing this project Q because 55.92 is greater than 0. We do not choose this project. Now, how to solve this NPV problem using the financial calculator? And as you know that from time value of money, you can see these cash flows look like uneven cash flows, right? So we have these uneven cash flows. Only thing difference is in present value, time value of money. We don't talk about the cost there, okay? But in capital budgeting, we're gonna have cost. So at time zero, we have this cost, okay? So let's use cash flow worksheet under financial calculator, and you press second and clear work. So you can clean the calculator. And first one is going to be C of 0, which is always negative. When you are doing time value of money problems, you used to put 0. But in this case, you're going to be putting negative 2,500. Enter, down, okay. Okay, now let's use the financial calculator. If you use the financial calculator, so this is basically TIPA2 plus financial calculator, and these are uneven cash flows. So we're going to be using cash flow worksheet. Press second and clear work. That's going to clear all the cash flow worksheet. And CF0, which is negative 2500. So put 2500 negative sign and enter. Go down. And you have C01, which is cash flow number 1. We have 1500. Let's put 1500, enter, down. And how many times you are getting 1500? Just one time. And the second cash flow is C02, which is CF2. We have $1,000. Enter, down. How many times? One time. Enter, down. The third cash flow is 500. So C03 is 500. Enter, down. And you are receiving that 500 only one time. Okay, and you enter, down, and your last cash flow is 100. So let's enter and down. Okay, uh, just for an example, if this cash flow is for 10 years, the 1500 is for 10 years, so it's going to be 10 years, then actually you don't have to put this number 10 times. You can just put this frequency equals to 10. Okay, all right. So once you put your cash flows in the cash flow worksheet, then you're gonna press second and quit. So you exit this cash flow worksheet. Then press NPV. As soon as you press NPV, you're gonna see I, which is interest rate. And in this example, we have discount rate is 12%. Okay, so let's put that 12%. Just put 12. Enter, down, and you will see NPV, and the calculator will show you compute. So just follow the screen. Okay, so press compute. You're going to receive 55.92. So this is how you're going to use financial calculator to find NPV. Do the same thing for the next project. Okay, you're going to receive 257.77 million. This is negative NPV project, so we don't accept this project, but we definitely accept this project because this is greater than 0. Okay, the other way to do this one is if you just want to put this one equals to, just leave 0. Basically you're going to get present value. Once you get the present value and you can deduct that 2500, again you're going to get the same thing. Okay, so do whatever way you feel comfortable, or you can use the formula, but which is a little bit more complicated. So I would definitely use either financial calculator or Excel. All right, so you definitely can use Excel spreadsheet to compute NPV. So first thing you need to do is you start with NPV function, and then you define your discount rate, and then you select all the cash flows, just cash inflows, okay, not the cost. And at the end you add your cost, because the cost is negative, that's why we're going to be using positive sign. Okay, so we're going to be using spreadsheet to compute NPV, and spreadsheets are one of the are the Excel, and we're going to be using spreadsheets to compute NPV, and spreadsheets are an excellent way to compute NPVs. Whenever you have uh, when you have to compute cash flows as well. Okay, so we're going to be using spreadsheets. Uh, so we're going to be using spreadsheets to compute NPV. Uh, Spreadsheets are excellent way to compute NPV. Okay, they are very. So we're going to be using Excel to compute NPV, and Actually, Excel is very easy to use to compute NPV. Okay, so I think by now most of you know how to find uh, NPV. So let's use Excel. Okay, so first of all, I would like to show you how to use the financial calculator. Same thing here. So this is the financial calculator solution, and if you use Excel, let me show you. This is pretty easy. Okay, so this one is I'm showing this calculation using Excel. So we start with function NPV. Okay, and start with a parenthesis and then rate. So this rate must be in decimal or in percentage. So since we have this number, in Excel, you can just click on the cell. Okay, so we have 12%, and then we have all values, all cash flows, not the cost. We select all the cash flows. Okay, so that's gonna give you the present value of all future cash flows. Then we have to take out the cost, right? So since this number is already negative, so if I put a minus here, it's gonna be minus minus plus. Okay, so I don't want that. Actually, this one here is computing NPV. So this one here is basically giving you present value of all future cash flows. Okay, so you have to add and select that number. That's how you can deduct that number, okay? Because this number is already minus. That is why I'm putting plus in Excel. Enter, okay? You got this 55.9. If you do the same thing for next project, okay, we start with NPV and rate is 12%, and we have these values, close plus project cost, enter. So you got NPV. Okay, so Excel is excellent way to compute net present value, IRR. So it's very handy, very easy. Sometimes even it's easier than your financial calculator. Okay, so let's go back to our presentation. Okay, so Excel is excellent. Excel is very easy to use, very easy, very handy to compute a net present value. What is NPV profile? If we graph net present value at a different discount rate, we can create NPV profile. Okay, so for example, in this project Q, if you find NPV with 0%, 5%, 10%, 15%, so you are using different discount rate and find NPV. Okay, and then plot this NPV at different discount rate. That's gonna give you NPV profile. Okay, that's gonna give you NPV profile. Wherever this NPV equals to 0, that's going to be your IRR. So here which is IRR, about 12%, right? No, actually 12% is discount rate, but IRR here is, I don't know, but I'll compute later on. Okay, so NPV profile is a, if you find, so NPV profile, what is NPV profile? Basically, if you find net present value of the project using different discount rate and plot them, that's the NPV profile. So we have here discount rate, and we have here on y-axis net present value. So this is NPV profile. Okay. Now let's talk about internal rate of return. Internal rate of return, which is also called IRR, is the discount rate that sets NPV to 0, which makes NPV equals to 0. Let's look this formula here. So if you set NPV equals to 0, okay, and solve this IRR, so basically we are using NPV formula, right? So NPV equals to 0, okay, and we don't know this IRR, so we solve for this IRR, okay. So IRR is the discount rate that makes NPV equals to 0. The minimum acceptance criteria for IRR is basically we're going to be accepting the project if the IRR is greater than the cost of capital. So IRR must be greater than the cost of capital. If we are talking about independent project, we're going to be accepting all the projects they have IRR equals to greater than the discount rate. All the projects with internal rate of return greater than the cost of capital. If the projects are mutually exclusive, because mutually exclusive means we can take only one project, right? So in that case, we're gonna be rank all these projects and take the one with the highest NPV. Again, they have to meet this criteria. And the assumption IRR makes is all future cash flows assumed reinvested at the internal rate of return. Okay? In NPV, reinvestment is a discount rate at cost of capital. In IRR, reinvestment at the internal rate of return. Okay? So the main advantages of IRR is easy to understand and communicate. Okay, it's a percentage, so very easy to understand. Everybody understands what is the percentage. 10% means. The main disadvantages of the internal rate of return are it does not distinguish between investing and borrowing. Okay, so it does not distinguish between investing and borrowing. That's the main problem. So whenever we have, borrowing situation, it does not distinguish. So the main disadvantages of internal rate of return are it does not distinguish between investing and borrowing. Sometimes IRR may not exist or there are multiple internal rate of returns and problems with mutually exclusive investments. Okay, so the main advantages of the internal rate of return is easy to understand and communicate. So it's in percentage, so you know very easily what is 10% means, what is 15% means. So there is no um, there is no confusion about dollar return and percentage return. So very easy to understand. But the main disadvantages of IRR are basically IRR does not distinguish between investing and borrowing. Sometimes IRR may not exist, or there may be multiple IRR. The problem with mutually exclusive investment, okay, so there are problems with IRR. So again, we are using this previous example. We are using project Q here, and so we just use the equation, NPV equation, let's set equals to 0 and solve for IRR. Okay, so this is a lot of algebra involved here in this solution. If you solve for IRR, you're going to receive 13.5%. Okay, if you have 13.5% in this project, your NPV is going to be 0. All right, so let's use a financial calculator. Again, there is no difference between using computing your NPV and IRR. So first thing, you're going to be using cash flow worksheet, put all the numbers, and here in this case, you press IRR. Okay, so here in this case, you press IRR. Okay, so now let's use the same example and compute IRR. Okay, so as you can see, there is no difference between NPV and IRR in terms of putting the cash flows in the calculator. So you use the same method to put the cash flows. Use cash flow worksheet, and once you finish entering all the numbers, okay. Now let's use the same example. We have project Q and project S, and let's enter the number. So you're going to be using this cash flow worksheet and enter the numbers. And once you put all the numbers there, quit cash flow worksheet and press IRR and just follow the screen. It says compute. So press compute. You'll receive 13.33%. According to the criteria, the rule, accept the project if IRR is greater than the discount rate. So here 13.5 is greater than 12%. So we're going to be accepting again this project Q. How about project S? Let's put the number in the cash flow worksheet on the calculator. Press IRR, compute. You're going to get 8.14%. So IRR for project S is less than the discount rate, 12%. So we're going to reject this project. Okay. You can also use this formula and find IRR for project S. Okay. So, whatever way you feel comfortable, you can do that. Just feel free to, whatever way you feel comfortable, feel free to use. We can also use Excel worksheet to compute internal rate of return. Okay, so let's use Excel worksheet. Okay, so project Q, equal, start with IRR, and now in this case, we're going to be selecting all the numbers here. Cost and cash flows, we're going to be selecting all these numbers. Select all the numbers, close the parentheses. and you got it. Okay, so in your Excel, if you have not formatted as percentage, you basically you need to click here this percentage, and just you want to have two decimals, so increase the decimal, so 13.12%, 13.5%. Same thing for other project. So we start with IRR and select all the numbers here. Okay, so you got it. Okay, so it's very easy to use Excel, in computing internal rate of return. All right, so let's go back to our presentation. So now you know how to compute IRR using Excel. Okay, so basically NPV and IRR, they give the same decision. Okay, in general case, but the exception are if there are non-conventional cash flows. That means the sign changes. So minus, plus. So if the cash flows are non-conventional, there is a problem. Okay, so you cannot. So now you know how to use Excel to find internal rate of return. So now you know how to use Excel to find internal rate of return. Now you know how to find Excel to compute internal rate of return. What is generally NPV and IRR give the same decision, but there are some exceptions. Okay, so basically, if the cash flows are non-conventional, that means cash flow sign change more than once. If the cash flows are non-conventional, that means cash flow signs change more than once. And if the projects are mutually exclusive and the initial investment are substantially different, and if there is a difference in timing of cash flows, there are two exceptions. In general, both NPV and IRR give the same decision. However, there are some exceptions. If the cash flows are non-conventional, that means cash flow signs change more than once. Or if the projects are mutually exclusive and initial investments are substantially different, or timing of cash flows is substantially different, then these two rules gonna give contradictory. They're gonna give you, these two rules produce different result. Okay, so the main problem with IRR are multiple IRRs, multiple internal rate of returns. So the main problems with IRR are multiple internal rate of returns. So we don't know, are we borrowing or lending? And there is a scale problem, and there is a timing problem. And I'm going to show you what are these problems. Okay, so let's look this example, and here in this case, I'm just doing different Q project. Okay, so it's not the same projects we are working. It is just a different Q project, and this project has non-conventional cash flows. Okay, so what does that mean is non-conventional cash flow means in time zero you have positive, and then all cash flows. Sorry. So in this example here, so there are two internal rate of return in this project. Which should we use? That's the problem with IRR. So that's what I'm referring to, multiple internal rate of return. Okay. So basically, non-conventional cash flows means, look at here, it's time zero and time 1, 2, 3, 4, 5. Okay. So in this example, we have negative and all these future cash flows are positive. So this is the example of normal cash flows. Okay. And let's look this second one, plus. This is minus, plus, 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 and minus. This is non-normal. Okay. So here is the problem. And this one here is minus, minus, minus. So basically here, this is minus. It's cost, but these are not cost. So this is the example of. So here is the minus, 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 and plus, plus, plus. This is the example of normal cash flow. Plus, 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 minus, minus, minus. Example of normal cash flow. Plus, plus, minus. Okay. So let's look here, and let's know. So as I explained earlier, internal rate of return has a problem because it can have multiple internal rate of return. Okay, so let's use another example here. This is project Q, and it's not the same example we used earlier. So this project has this is cost, and these are cash flows, and basically the last cash flow is negative. Okay, so this is non-normal cash flow. Okay, in this project, because if it has more than one time sign change, this is non-normal cash flow example. Let's look here. If this, in this case, we have only one time change in the sign, so it's normal. In this case, we have two times change, one time, two times sign change is non-normal. Here is it's normal. This one is normal, and this one is non-normal. So if the cash flow sign is changed more than once, that's the example of non-normal cash flows. Okay, so in this case, there are two internal rate of return, and which should you use? So that's the big problem with internal rate of return. Okay, so in this project, let's find out net present value using different discount rate. Okay, find net present value using different discount rate, and if you create NPV profile, it's going to be look like that. Okay, it's going to be look just like this. So in normal situation, when the discount rate decreases, when the discount rate increases, the net present value should go down. Right? Or when the discount rate increases, net present value okay. So first find the net present value using different discount rate. and create an NPV profile. And look at this one here. You can see that as the discount rate increases, NPV increases. And here we have, because this is 1 0, right? So we should have one internal rate of return here. And again, NPV is 0 here. So we have the second internal rate of return. So we have 1, 2 internal rate of return. That's what I'm referring to. 2 internal rate of return. So we're gonna be basically have 2 internal rate of return, and both of them they're gonna give 0 NPV. Okay. So let's look this example. Let's do this example in Excel. Okay, so this is the Excel, and what I'm doing here is, let me show you here. I'm finding NPV using, so NPV in rate is 0%, and values are these values, and plus this number. Okay, so I have one NPV. So if I just want these numbers to be absolute number. Okay, so I want to um, let's use, okay, and I want this because I just want to make this cell reference, non-changing. So I want to put a dollar sign here in front of them, so I can press F4. Okay, press F4. So, and then also this one also we don't want to keep on changing. So press F4. We just want discount rate changing, but all these value still same. Okay, so let's drag down. All right, so once you have this NPV in different discount rate, what you can do here is just select this number, and you can put insert, and you can create a scatter plot chart here. Click here. So this is how you're going to be creating NPV profile. Okay, so I already have this one here just to make it easier. So as you can see that this is one time in NPV equals to 0, and this is the another time NPV equals to 0. This is because we have non-conventional cash flows. Okay, so when you have non-conventional cash flows, there are two internal rate of return, multiple internal rate of return. Whenever you have non-conventional cash flows, you have more than one internal rate of return. So in this case, we have two returns. So let's find them. Okay, so as you know that IRR equals to, so we have values. Okay, now let's guess that comma, and let's guess probably, as you can see here, it's about 10%, right? So let's guess 10% and close. So we got 8.78%. Okay, our another internal rate of return equals to IRR. Again, we're going to be selecting these values, and we have this case. So this one is about, let's put 25%. So 0.25. So 26.65%. Okay. So definitely there are two different internal rate of return. Now let's find NPV using these two different rates. NPV equals to, you start with rate and then select these numbers and plus here. So you have NPV. So as you can see, this one NPV equals to 0. Same thing, other one also is going to produce its NPV equals to 0. Okay. So there is a big problem with internal rate of return. If the cash flows are non-conventional. Okay, so let's go back to our presentation. Another problem with internal rate of return is a scale problem. Okay, so would you rather make 100% or 50% on your investment? What if the 100% return is on $1 and 50% return is on $1,000? So which one would you choose? That's the problem, right? That's called scale problem. All right. So let's take a look on this example. It's a different. We have two projects, project A and B, and if the cost of capital is 10%, let's find out NPV, IRR, and on these projects. Okay. So if you find NPV, the project A is going to have 2,092.13 dollar NPV, while project B is going to have 500. The project B is going to have $582.29. Okay, so look at this one, the scale problem. We have 10,000 and 1,000. Okay, so we have $10,000 investment and $1,000 investment. So this is the example of scale problem. Okay, it's just like example of $1 investment and $1,000 investment. Okay, so if you find NPV here for project A, we have $2,092.13. For project B, we have 588.29. So basically, based on NPV, project A is superior to project B. Okay. If you look internal rate of return, if you find internal rate of return on these two projects, we're going to have 20.27% for the project A and 36.08% for project B. Okay. So now we have the conflict. As I mentioned earlier, generally NPV and IRR rules give the same decision. But in this case, we have conflicting results. Okay, conflicting decision. IRR says project A, IRR, we have conflicting decision here. As I mentioned earlier, NPV and IRR rules should give the same conclusion. But as you can see here, NPV prefers project A, IRR prefers project B. So IRR conflicts with NPV. This is because of the scale problem. Okay, so this is another type of problem with internal rate of return. And we can find out modified internal rate of return, but still modified rate of return, internal rate of return cannot solve this problem either. Still, MIRR also has the scale problem. Okay, so this is the example of a scale problem. Let's look another problem here. Another problem here is okay. So this is very good example of a scale problem with internal rate of return. Finding cross rate. Cross rate is basically the change in the internal rate of return. Okay, to find the cross rate, to calculate the cross rate, so here let's find out the cross rate. Okay, to find the cross rate, calculate the difference of the cash flows in each period. So calculate the difference in cash flows here. So this minus this is 0. So let's find the difference here. So I found all these difference here. Find the difference and find internal rate of return on that difference. That's going to be cross rate. Okay, so that's going to be one thing you're going to be looking. And then the second thing is using different discount rate, find NPV of both of these projects and create a NPV profile. Okay, when you create a NPV profile, as you can see that this is the cross rate. So this is where net present value of these two projects, they're going to be similar. Okay, so this is the cross rate. And if the discount rate is less than the cross rate, and if the discount rate is more than the cross rate, you can see conflicting decision, right? NPV says, NPV prefers here in this case this project, so Q project. And if the discount rate is less than the cross rate, actually project Q has higher NPV. So this is conflicting results here. Okay, so this is because of the timing of the cash flow. As you can see that the first project has bigger cash flow in the beginning and smaller cash flow at the end, and the second project has smaller cash flow in the beginning and bigger cash flows at the end. Okay, so we have the conflicts here, and the main objective of this instruction here is I would like you to know how to find out the cross rate. Okay, so let's find out the cross rate using Excel. Okay, so to find the cross rate, first find the difference. So find the difference is this minus this. Okay, and do the same thing here. And here is IRR, and select this difference. Okay, close. We have IRR 2.22%. Okay, and plot them, and then show the cross rate here. So it's pretty easy to find out the cross rate. And again, finding this NPV profile, plotting NPV profile, basically in different rate of return, discount rate, you're going to be computing this NPV for each of these projects, and you're going to be selecting whole thing and go to insert, click on scatter plot here, and just choose the one you like. So this is how you're going to be creating our NPV profile. Okay, so now let's get back to let's go back to our presentation. Okay, so this is how you're going to be finding cross rate. Why NPV profile cross? There is a cross in NPV profile because of two reasons. One is its scale difference, other one is timing difference. Okay, so scale difference is basically the smaller project fee frees up front at time 0 for investment. So scale difference is basically the smaller project frees up front. So the size difference is basically because of because the smaller project frees up funds at time zero for investment, and the higher opportunity cost, the more valuable these funds. So a high WACC favors small projects. Okay, that is the size problem. The timing difference is the projects with faster payback periods. Faster payback provides more cash flows in early years for the reinvestment. So if WACC is high, early cash flows, especially good. So NPVS is greater than NPVL. Okay, so NPVS is greater than NPVL. Okay, so NPV and IRR may conflict for mutually exclusive project. Okay, so now you know how to find out cross rate using Excel, and you can use the same cash flow worksheet and find internal rate of return. Okay, that's going to be cross rate, but I think it's going to be easier in Excel because you don't have to worry about that sign problem. So NPV and internal rate of return may conflict for mutually exclusive projects, and the conflict is because of the size difference and the timing difference. Size is basically the investment. Okay, so the smaller projects frees up fund a time T for investment. Okay, so the higher the opportunity cost, the more valuable of these funds. Okay, so higher the opportunity cost, the more valuable these funds. So a high WACC favors small projects. Okay, so that's what you can see here. High WACC, you know, favors small project. Okay, so in this case, this project, yes, right? So this project S, okay. So NPV and internal rate of return may conflict for mutually exclusive projects. The reason for that is because of the size difference and the timing difference. The smaller project frees up funds at time zero for investment. Okay, therefore, opportunity cost. Therefore, the higher the opportunity cost, the more valuable these funds are. So, a high WACC favors small projects. So, in this case, high WACC favors small project. Okay, that is why this project S is more valuable here. Uh, just before this cross rate. Okay, and the timing difference, the project with faster payback periods provide more cash flows in early time period. Okay, for reinvestment. Therefore, WACC. Therefore, if WACC is high, early cash flow is especially good. If cash flow, okay, so NPV and internal rate of return may conflict for mutually exclusive project, and the conflict is because of the size and timing difference of these cash flows. Okay, so basically, in this case here, we have okay. So NPV and internal rate of return may conflict for mutually exclusive projects, and the conflict is because of the size difference. So if there is small investment at project at time zero, so what's going to happen is it's the project frees up the cash flows, frees up of the investment for future, frees up, um, okay, the NPV and internal rate of return may conflict for mutually exclusive projects. Okay, so the conflict between these two rules is basically because of the size or scale difference and the timing difference. So size difference means the size of the investment. So smaller projects frees up fund at time zero for investment. Therefore, the higher the opportunity cost, the more valuable are um, the funds. So a high WACC favors small projects. Okay, therefore this project S is favorable here. Similarly, the timing difference. Um, if you have higher cash flows in the beginning of the project, so that means the project has, the project with faster payback period provides more cash flows in early years for reinvestment. Therefore, WACC. So if the WACC is high, therefore, if the WACC is high, early cash flows are good. Okay, therefore project S is preferable to project L. Okay, so project S is preferable to project L here. That's the difference. That's the reason for this conflict. Okay, so hope you understand why this NPV profile crossover. The whole reason is because of the size and time difference of the cash flows. When you have size difference of the investment and a smaller project frees up um, cash for investment, future investment. Okay, so high WACC favors small projects here. That's why this project is more preferable here before the cross rate. Similarly, the timing difference. If there are high cash flows in the beginning, larger cash flows in the beginning, that means projects with a faster payback period, so provides more investment, more resources for reinvestment. Therefore, um, w, if WACC is high, early cash flows are good. Okay, therefore this project is more preferable. So whenever the discount rate is higher than the cross rate, okay, the smaller projects are better, and or the projects with higher cash flow in the beginning are better. That's why it's conflict. But if the discount rate is smaller than the cross rate, then in that case we prefer better project. We prefer project Q because we don't have that problem. Okay. So now to address the problem with internal rate of return, we can use modified internal rate of return. So what is modified internal rate of return? MIRR is also the discount rate that makes the present value of investment outlays equal to the present value of the project's terminal value. Okay, so basically you have the cash negative cash flows here, all the cash flows with negative sign here one side, and discount them. So find the present value of all negative cash flows. Okay, using the discount rate, using the project's discount rate, and find the future value of all positive cash flows. Okay, so all positive cash flows. Find the future value of all positive cash flows using the discount rate. Okay, so how do you make these two similar? The internal modified internal rate of return will make that two cash flows. Okay, present value of all negative cash flows and future value of all positive cash flows equal by this modified internal rate of return. Okay, so this is how you're going to be finding modified internal rate of return. Okay, so basically modified internal rate of return is a discount rate that makes the present value of all negative cash flows equal to the future value of all positive cash flows. It is the example of multi-period cash flows. And if you have one period cash flows, you can use this formula. Okay, so the basic assumption of modified internal rate of return is um, it assumes that reinvestment at cost of capital, and again, except it if MIRR is greater than the required rate of return. Okay, so the main benefit is a single answer and specific rates for borrowing and reinvestment. Okay, so MIRR solves some of the problems with internal rate of return. For example, with MIRR now we don't have the problem with multiple uh, internal rate of return, so we'll have only single rate for both borrowing and lending and investing. So even if you have a non-conventional cash flow, still you're going to have the same single discount rate. Okay, so that's the big advantage, but it's still MIRR has a scale problem. So basically MIRR, so basically the modified internal rate of return is the discount rate that causes the project's cost, okay, equal to project's present value of terminal value. Okay, so present value of terminal value, and the terminal value is defined as the sum of the future values of the project's cash flow computed at the project's cost of capital. Okay, so MIRR, to calculate MIRR, you need to calculate present value of negative cash flows. Okay, and find the future value of positive cash flows using the cost of capital and equate them. Okay, or you can use Excel. Okay, so this is present value of all future cash flows, all negative cash flows. This is future value of all positive cash flows, and the discount rate that equates uh, the present value of negative cash flows and future value of positive cash flow. Because by doing this one, you are finding the present value of all future cash flows, right? So all positive cash flows. So this MIRR is gonna make these two equal. Okay, so what you need to do is, first thing you need to do is find the future value of positive cash flows. In this example, we have all cash flows are positive, so let's find the future value of all these positive cash flows. And negative cash flow in this case is for this project Q, we have 2500. Okay, so 2500 equals to this future value of all future cash flows. Okay, positive cash flows. Now, this solve for MIRR and you're going to receive that 12.62%. Okay, so it's a little bit complicated, just looking this one, but it can be. I'll show you the steps using the financial calculator. So how to find MIRR using financial calculator? So basically, first use TVM keys Okay, time value of money keys if the cash flows are even, or use cash flow worksheet. Uh, okay, and find out NPV first. And using that information, find future value, because we don't have any FD function on Excel or financial calculator. So first of all, if you have even cash flow, then you definitely can find future value. Okay, you don't have to do extra step. But if you have uneven cash flow, first find NPV, then find out the future value using that NPV. Number two, you're gonna be finding the present value of negative cash flows. Okay, so find the present value of negative cash flow. In step three, use the information you receive from step one, step two, and other information. Okay, and use the 5 keys in your calculator and solve for I by Y. That is the modified internal rate of return. Okay, or you can use Excel formula, Excel function. So you can use equal to MIRR and select all the values and put finance rate and reinvestment rate. So that rate could be the discount rate, okay, in this both case. So you have to select both of them and you're going to get MIRR. Okay, so let's use the same example and find out modified internal rate of return. So let's use the second project here. So our CF0, because first find the future value of all positive cash flows. Okay, so at time 0 we have negative, so we put 0 for that. At time 1 we have 200. So at time 2, so cash flow 2 is 500, cash flow 3 is 1000, cash flow 4 is 1500. So using NPV, put I equals to 12% and go down and compute NPV. You're gonna get 2242.23. That's the net present value. Okay, but we need to find out the future value. So using the 5 keys, find the future value. Okay, so we have 4 years. We have discount rate is 12%, and the present value is 2242.23. And since you already used the payments to find NPV, so now we're going to be using 0 payments equals to 0 and compute future value. You get $3,528.19. Okay, so you found the future value of all positive cash flows. Now present value of all negative cash flows. In this case, we have only um, negative 2500 for CF0. Okay, so in this case, we have only one negative cash flow, which is cash outflow at time 0. Okay, the step 3. Now use the information you found in step 1 and 2 and other information. So we need N. N is, in this case, we have 4 years. So let's put 4. Present value is the negative, okay, from step 2. And the payment is 0. Okay, and future value is from step 1. And compute I by Y, you're gonna get 8.99%. This is this is MIR of the project S, and you can definitely use Excel function. So let's use Excel function. It's very easy to use in Excel. Okay, but still you're gonna go through these steps, because even in Excel we don't have direct future value calculation. So let's use Excel now to find modified internal rate of return. Okay, so we have the same project QNS. Okay, so first of all, you need to find out the net present value. Okay, so to find net present value, you have NPV, and then you have the rate, which is 12%, and you select these numbers, and plus cost here. So we have NPV. Okay, once you have NPV, find out the future value using that NPV. So in this case, we have N equals to 4 because we have 4 years, 1, 2, 3, 4, and 12%. So present value is 55. That's the same as NPV. And payment is 0. Compute future value. You're gonna get 8799. Okay. So you use future value. And you have rate is 12%. So rate is 12%, and your N is 4, and payment is 0, and your present value is this number, and type here is does not matter. So let's put the 1 anyway. Okay, so you got $87.99. That's a future value of all positive cash flow. Step 1. Okay, step 2. Find the present value of all negative numbers. So in this case, we have only one negative number. Okay, we have negative number here, present value. Now, step 3, use the information from step 1 and step 2 and other information, and use these 5 keys in your calculator. So you have, you start with equal rate, okay, basically I'm using here, I'm showing you, financial calculator. So basically, let me just put that 12.62. Okay, so this is how you're going to be using financial calculator. Step 1, find the future value of all positive cash flow. Step 2, find the present value of all negative cash flows. And step 3, use 5 keys to solve for I by Y, which is MIRR. Okay, using Excel is pretty easy. Equals to MIRR. You select all these numbers. You're done. Oh, okay. Here. So let's use Excel to find MIRR. Okay. So let's start with MIRR parenthesis and select all the values. Okay, and let's look here in this formula, comma, and finance rate. So finance rate is cost of capital, 12%, and a reinvestment rate. In this case, MIRR assume that the cash flows they're going to be reinvestment rate, and they're going to be reinvested at the discount rate. So let's use the same rate. Okay, enter. So you got 12.62%. So using Excel is pretty easy in calculating MIRR. Okay, so it's very easy to find MIRR using Excel. If you use financial calculator, you have to go through these steps. Okay, so it's up to you. But I think in this case, Excel is a lot easier. But you need to know both ways. Okay, so let's get back to our presentation. So now, you know how to use financial calculator, how to use Excel to compute modified internal rate of return. Okay, So the main advantage of modified internal rate of return are it assumes that cash flows reinvested. Um, it the main advantages of modified internal rate of returns are so there's some advantages of modified internal rate of return. It assumes that cash flows received are reinvested at the cost of capital, not internal rate of return. Since a reinvestment at the cost of capital is more likely, the MIRR is better indicator of a project's profitability. Okay. Um, MIRR also solves the multiple internal rate of return problem. Okay. So even you have non-conventional cash flows, still we're going to have only one MIRR. So it solves the problem of modified internal rate of return, which gives different internal rate of return. Okay, multiple internal rate of return. It is similar to net present value, and it is easy to understand and communicate because it's a percentage, and there is no confusion of dollar return and percentage return. Okay, still MIRR is not free from problems. MIRR cannot solve the scale problem in a mutually exclusive projects. So it still lead to incorrect decisions for some mutually exclusive projects. That's the problem with modified internal rate of return. But it's gonna solve most of the problems with internal rate of return. Okay, so let's look this another example here. This example is basically for you to practice. Okay, here we have project L and M, and I have the solution answer for you, so you can look the solution and try to find out um, NPV, IRR, MIRR. Okay, and as you can see that here project M is preferable to project L, using NPV criteria, but project using internal rate of return, basically since this non-conventional cash flows, MIR, its internal rate of return is going to be multiple. Okay, so we have two for project L and two for project A. Okay, so as you can see that IRR gives conflicting results, right? Because it prefers project project L. So let's see this first one, project L. Okay, and it has two uh, internal rate of return, two IRR, multiple IRRs. So which one should you use? It's difficult, right? So we cannot. This is the problem, big problem. And you can compute MIRR. Now, when you compute MIRR, as you can see that both NPV rule and IRR rule, they give us the same decision. Okay. So now let's talk about another, techniques we can use to find if a project is a good project or unacceptable project. So the payback period. Payback period is defined as the expected number of years required to recover the investment, and it was the first formal method used to evaluate capital budgeting projects. It basically tells how long it takes the project to pay back its initial investment. Okay, so payback period equals to number of years to recover initial cost. All right, and then the decision criteria is set by the management, and basically accept the project if the payback period is less than the targeted payback period. So it's set by management. There is no rule hard and fast, but it's going to be set by the management. And ranking criteria also is set by the management, but basically if you have mutually exclusive project, rank based on payback period and choose the one with the lowest payback period. Okay, if independent projects, then choose all the projects they meet this criteria. And the main disadvantages of payback periods are it ignores the time value of money, so that's a big problem. So it treats $1 today and $1 in future same way. That's the biggest problem. Ignores cash flows after the payback period. Okay, so some projects can have larger cash flows in the beginning, and some have larger cash flows at the end or in future. So IRR does not consider cash flows after the payback period. Sorry, payback period does not consider cash flows after the payback period. Okay, after um, the recovery. Bias against long-term projects. Okay, so it's really biased on long-term projects and requires an arbitrary acceptance criteria. So the acceptance criteria is set by the management, which is very arbitrary. Project accepted. Project is accepted based on the payback criteria may not have the positive NPV. Okay, so it might not have the positive NPV. That's another big problem. The advantages, very easy to understand and provides an indication of project's risk and liquidity. Okay, and basically payback period is number of years are required to recover the cost. Okay, so basically what you're going to be doing here is you have the cash flows, cash cost and cash flows. So in year one, your cash inflow minus cost, actually your cost, so when you, how you compute a payback period. So basically payback period equals to number of years prior to full recovery, and then the part of the unrecovered cost at the start of the year, and then the cash flow during the year, during the recovery year. Okay, so let's look this example. So you have $2,500. This is the cost, and first year you got 1,500. So 25 minus 1,500 is still 1,000 left. So in second year you got cover all this cost, right? So you're going to be basically looking between negative and positive cumulative cash flows. Okay, so in this case we have 2 years plus 0 over 500. Okay, so basically it's going to be 2 years. If you now you compute payback period for project another project here, project S. So you have 2,500. So 2,500 minus 200 is still 2,300 left, and 2,300 minus 500 is still negative 1,800 left. And year three, you get positive 1,000, is still $800 left. So now 800, and next year is 1,500. So only the part you need to cover is 800. So 3 plus 800. 800 is the part of the uncovered cost at the start of the fourth year, and divided by 1,500, which is the cash flow during the year. Okay, that's gonna give us the part of the year 4. Okay, so it's gonna be 3.53. Let's watch this short video clip, which gives a really good overview of payback period. Let's watch. Let's watch. Let's watch a very short video clip which gives a good overview of payback period.
What are the advantages and disadvantages of the payback approach? The payback tells us the number of years or periods it takes to recover a project's upfront cost. The general sense is the quicker the payback, the better the project, and that weaker projects or projects that aren't as good typically have longer paybacks. Now, there are two key advantages and perhaps two key disadvantages of the payback approach. First, the advantages. One advantage of the payback approach is it's simple. It's easy to understand. It also gives us a rough idea of how long it takes for a project to contribute to earnings. I mean, with that in mind, I know when I grew up that this is the approach my parents often used with me to evaluate projects. If I came in and wanted to borrow $20, the question they asked generally was, when do we expect to get paid back? They didn't ask for the projects like NPV or the IRR. They just wanted to know when they were going to get their money back. Same thing holds true for corporate managers. Corporate managers often want to get a sense when they delegate money to project managers, when is this project going to be contributing to earnings? So again, there's this sense that it's a simple rule of thumb we can use to evaluate how likely it is that a project is going to be paying off and how soon we're going to be getting the cash back. Despite those advantages, there are a number of key disadvantages, two in particular that arise when using the payback approach. One is the simple payback approach ignores the time value of money. Now in the text we talk about a way around that problem by using the discounted payback approach, but we're still left with a larger problem. The larger problem is the payback approach ignores cash flows that occur after the payback period. What do I mean by that? Well, let's say you have a company that follows a simple rule of thumb that says we're only going to accept projects that pay themselves off in 3 years or less. Now let's also assume we have this hypothetical project that costs $100 today, gives us nothing for 4 years, and then gives us $70 million at year 5. Now strictly speaking, that project has not paid itself off in 3 years. It took more than 3 years to get $100 back. But clearly all of us recognize that this is a good project. Anything that takes $100 and turns it into $70 million 5 years later is a good project. So there's a very vivid illustration of where the payback approach falls short and where it leads us to make a wrong decision. Now, I by no means would suggest that there's any company out there, any investor out there that would turn down this hypothetical project. At the same time, I think it's important to understand that a lot of companies make their small decisions using things like the payback or simple rules of thumb. And while you're not making the same kind of mistakes you would with big projects, a lot of times these small projects add up. So I think that's why we generally advise people when it comes to make investment decisions to rely on other measures, including NPV and the internal rate of return.
So, so now you know that what are the advantages and disadvantages of payback period, and this is a very simple criteria, simple method to use, but it has a lot of disadvantages. To address the problem with payback period, we can use discounted payback period. So basically, discounted payback period is defined as expected number of years required to recover the initial investment after taking the time value of money into account. So basically, you're going to be using cumulative discounted cash flows to find out the payback period. So basically, discounted payback period and payback period are same, except we're going to be using time value of money. Uh, you know, we're going to be uh, using discount. We're going to be using discounted cash flows. Okay. So again, how long does it take the project to pay back its initial investment, taking the investment time value of money into account? Decision rule, again, accept the project if payback periods uh, on discounted basis is less than the targeted payback period. Okay. And if you have mutually exclusive projects, again, you're going to have the ranking and choose the one with the lowest payback period. Okay, so let's move on. So in this example, as you know that you're going to be using the same formula, except you're going to be using cumulative discounted cash flows. Okay, so first you're going to be you're going to be using discounted cash flows here. So you discount 1500 by dividing 1 plus uh, discount rate. So it's this one. So here the second cash flow is 1000 divided by 1 plus r raised to 2. So this is how you're going to find the present value of all these cash flows and use those discounted cash flows to find out the payback period. So in this case for project Q, we have in the second year still we have left. So in the third year still we have $7.63 left. So So basically, you're going to be looking this negative and positive here. So we still have year 4, we still have $7.63 to be recovered. So we have 3 plus 7.63 divided by the discounted cash flow for the next year. So 63.55, which gives us 3.12 years for the project Q. So definitely discounted payback period is better than the regular payback period, since it's using time value of money. Okay, and for the project B, it's gonna take more than 4 years, so we don't have the information for year 5, so it's gonna be 4+ years. Okay, all right. So discounted payback period also. So discounted payback period consider time value of money, but it still has other problems of the regular payback period. Okay, our last criteria is profitability index. So basically, profitability index is the present value of all future cash flows divided by the initial cost, and it measures the present value per dollar of investment. Okay, so here we have profitability index PI equals to total present value of all future cash flows divided by investment, initial investment. Okay, so again, the minimum acceptance criteria is PI should be greater than 1, because 1 is cost and it has to be more than 1. So okay, so ranking is basically select the one with highest PI. Okay, if you have mutually exclusive projects, choose the one with the highest profitability index. First, it has to meet this criteria. Okay, let's look the PI for project Q. So basically, you are finding the present value of all future cash flows and dividing by your cost. So 1.02. That means $1 is cost, 0.2 is your benefit. Okay, so it's giving every single dollar you invest, you're gonna make 2 cents. Okay, every single dollar you are investing, you are making 2 cents. Okay, so now you compute PI for project S. So if you get 0.9 or 90 cents, that means you are right. But look at this. This is less than 1, so you are not even getting your cost. So you should not choose this project, yes, even based on profitability index criteria. Okay, so the main advantages of profitability index are basically it may be useful when available investment funds are limited. So we're talking about capital rationing. So if you have limited budget, so yes, we have limited budget, we have capital rationing problem. So in that case, maybe it's useful, easy to understand and easy to use. Okay, and correct decision when evaluating independent projects. Okay, if you are evaluating independent projects, it can give you really good decision. The main disadvantage of the PI is basically problems with mutually exclusive investment. So main problem is scale problem. Again, this PI for $1 investment or $1 million investment, so it has a big problem with this profitability index. So it's scale problem. All right. So summarizing this example, project Q and S we have been doing. So basically, I have summarized all the answer here. Project Q is superior to project S based on NPV, based on IRR, based on MIRR, based on everything, right? So not this is not a typical situation. You could have different situation. You could have different cash flows. You have non-normal cash flows. You could have scale problems. So there could be several problems. But in this example, we have solid decision: NPV, IRR, MIRR, payback period, discounted payback period, and PI, everything is giving solid decision is the project Q. And I want you to try, make sure you can find these numbers, okay? And also try the example with non-conventional cash flow and try to find out these. Other issues in capital budgeting, in the real world, capital budgeting problems are not simple. If two mutually exclusive projects have different lives, and if the projects can be repeated, then it is necessary to deal explicitly with those unequal lives. So basically, you could have projects with unequal lives. Okay, we use two approaches to solve those type of problems. Okay, if you have even life of the project, it's not a problem. But if you have different lives of the project, then we need to find out which project is better project. So we use common life approach and equivalent annual annuity approach. So let's look what are those approaches are. So we have project X and project Y. Project X is 6-year project. Project Y is 3 years project. Okay. So we can solve this problem because it's not a regular capital budgeting problem, but this one has unequal lives. These two projects, they do not have equal lives. Okay, so we can adopt common life approach to solve. Okay, when you use common life approach, you're gonna be repeat your project with shorter lives. Okay, so basically we are uh, repeating project Y. So here 0, 1, 2, 3, and in year 3 we're gonna repeat this one because year 3 is basically time 0 for next term. So again repeat this one and then find the cumulative cash flows here. So year 0, 1, 2, we are copying this number, but year 3 we have positive cash flow and then we have cost, so negative 8,000. In year 4, 7, 5, 13,000 and 6, 12,000. So what we are doing here is, so we are extending the life of this second project, which has shorter life, making the similar. Okay, so now we have similar lives of these two projects. Okay, so we have similar lives of these two projects. Okay, now find NPV, IRR. So NPV of these two projects. So Y is superior. Find IRR of these two projects. Project Y is superior. Okay, find MIRR, project Y again superior, profitability index, project Y is superior. Okay, and please try to find these numbers. And IRR has a problem here because for the second project, because this is a non-conventional cash flow. So in this case, we have two multiple internal rate of return. But basically, financial calculator and Excel, if you use IRR function, they give the lower one. Okay, so to find the higher IRR, you have to put the guess function there. All right, so this is one approach, common life approach. Extend the life of the projects, make similar, and find NPV or IRR or whatever capital budgeting techniques you are using. Okay. Second approach. So second approach is basically find out the equivalent annuity. Okay, equivalent annual annuity. So what you're going to be doing here is find the net present value of both of these projects without extending. Okay, find NPV of both of these projects using NPV function in Excel, or find NPV using financial calculator. And in step 2, using the 5 keys or Excel function, solve for payment. Okay, because we are trying to find out equivalent annuity, right? So that means in terms of annual um, benefit, how much is each of these projects generating. So if you solve for payments for project X, we're gonna get 1578.76, and for project Y we get 2146.23. Okay, so which one is superior here in terms of payments? Okay, definitely project Y has higher annuity, so we're going to be selecting project Y in this case. Okay, so let's look the first approach. Again, we have project Y is superior. Okay, if you use this approach, again project Y is superior. Okay, so you can use one of these two approaches if the lives of the projects they are not similar. All right, so just summarizing all the criteria, capital budgeting techniques. So if you have mutually exclusive projects, NPV except the one with NPV greater than 0, IRR and MIRR, they have to be greater than the cost of capital if independent projects, and if mutually exclusive, rank the one with highest NPV or IRR or MIRR. If cost is greater than MIRR or IRR, do not take those projects. Discounted payback or payback period has to be less than the targeted recovery period, and choose the one with highest if the mutually exclusive, and choose all of them if independent. Okay, PI again, choose the one with greater than 1, and if independent, take all of the projects which has PI is greater than 1, and if it's mutually exclusive, take the one with the highest PI. Okay, so this is the summary. And before I finish this topic, I just briefly want to talk about capital rationing. In the real life, companies or investment, investors, they do not have. There is a capital. And before completing this topic, before finishing this topic, I would like to talk about capital rationing. We have a capital constant. Companies, they have capital constant. They cannot choose all the projects with the positive NPV. Okay, so company typically set an upper limit to on the total amount of capital expenditure that it will make in the upcoming year. The reason for that is basically companies want to avoid the direct cost, rotation cost, and indirect cost of issuing new capital. Okay, so the solution for that is increase the cost of capital by enough to reflect all of these costs, and then accept all the projects that still have a positive NPV with the higher cost of capital. Okay, another reason is companies do not have enough managerial marketing engineering staff to implement all positive NPV projects. So in that case, use linear programming to maximize NPV, subject to not exceeding the constraint on the staffing. Okay. Another reason is companies believe that projects manager forecast unreasonably high cash flow estimates. So companies filter out the worst project by limiting the total amount of projects that can be accepted. Okay, in that case, implement a post-audit process and tie the manager's compensation to subsequent performance of the project. Okay, so you can deal with this problem, capital rationing problems by several means, but if you have capital constraint, you cannot take all the positive NPV projects. That's the whole idea about capital constraint. So, in practice, which rules are widely used? Well, the research have shown that um, about 75% of US and Canadian firms they use NPV, and 57% use payback period, and NPV and IRRs. Well, now which rules are okay? Now which rules are widely used? Graham and Harvey 2001 published a paper, and they report that about 75% of the US and Canadian firms they use an net present value technique. Okay, so now most frequently, so which capital budgeting techniques are used by the companies? Okay, so most frequently used techniques for large corporations um, are NPV and internal rate of return. Graham and Harvey 2001 published a paper and reported that about 75% of the US firms and Canadian firms use NPV and IRR. 57% use payback period. Okay, and this looks unusual because 57%. Okay, now which capital budgeting technique is popular or widely used? Most frequently used techniques for capital budgeting are NPV and IRR. Okay, Graham and Harvey published a paper in 2001, and they reported that about 75% of the US and Canadian firms use NPV and IRR, and rest use the payback period. Okay, large firms are more likely to use NPV or IRR, and small firms use payback period almost as much as NPV and internal rate of return. This is not like 100% with certainty, but this is the trend. Since NPV, is basically since NPV um, since NPV rules, choose the project that adds value. Uh, they increase the value of a company. Okay, so with this, we are done with today's class, and I'll see you in the next class. Thank you. So, which techniques are better? Well, the most frequently used techniques for large firms in large corporation are NPV and internal rate of return. Graham and Harvey published a paper in 2001 and found that about 75% of the US and Canadian firms use the NPV and internal rate of return, and rest use the payback period. Large firms more likely to use NPV or large firms more likely to use the net present value or internal rate of return, and small firms use payback period. Almost as much as NPV and internal rate of return. Okay, so with this, we are done with this chapter, and I'll see you in my next class. Thank you for your attention. With this, we are done with this chapter, and thank you for your attention. See you in the next class. Well, with this, we are done with this chapter. Thank you for your attention. Well,